everyone, and welcome to this tutorial on how to do your assignment 2 in about 10 lines of code using SFU's own DataPrep library. This is made by SFU's database team, and you'll see how easy it is to fetch these tweets from Twitter and then plot the frequency distribution, so the word and how many times the word has appeared in a tweet, word cloud, and other statistics, right? So those who are not familiar with assignment 2, for CMPD 456, the problem statement was to get 1,000 random tweets from Twitter and then plot the frequency distribution, the word cloud, and other statistical analysis related to those, and do the same for tweets with the COVID-19 word in them, right? Uh, so again, our assignment had about 150 lines of code, right? 150 to 200 lines of code. And what we'll see is we can achieve the same with about 10 lines of code using DataPrep. So the first step would be to install DataPrep. So you'll run this cell. Because I have it installed, I won't run it. And another thing is I'm going to share this notebook in the link below the YouTube video, okay? After we install our DataPrep, what we'll do is we'll import the data connector object from a data connector module. So from dataprep.data connector, import connector. The next thing would be to get client ID and client secret. This you'll get from the Twitter when you register for the developer account. Once you have those, you'll instantiate a DC object. And how you do that? You do DC equals connector that we imported. The first would be Twitter, because we are using the Twitter connector. For authentication, we have key value pairs. So client ID will have the client ID value, and the client secret will have the client secret value. Once we run this, we'll have a DC object, right? So let's run our DC object. So once we run our DC object, we'll have this. So we have a tweets table right here, and it takes parameters, which is Q is a required parameter. That's a query parameter. Count and max ID are optional. And these are the sample methods that we can run on our connector object. So let's run the show schema and the tweets table, right? So show schema of the tweets table. So we have 6 columns, right? Created at text, truncated, language, hashtag ID. The ones we're interested in are text and ISO language code. So now we'll fetch 1,000 tweets. So how do we do that, right? So once we use the query method, but before we do that, I'll just say the thing that we return, what we get back from this is a data frame. And having a data frame would make our life so much easier, right? So now let's see how do we fetch that. So we do dc.query. Tweets would be the table name. So tweets. Q is the query. So this would be for COVID-19. So COVID-19, right? And then the count would be 1,000. So if you want to get random tweets, right? So for that, it would be false. But for this, it's COVID-19. So let's keep back to COVID-19. Once we run that, a data frame object will have all these columns, right? So now we only want the English language tweets. So we'll filter where the language code is EN. So df is equals to df, or language code is equals to EN, and we'll reset the index. This is an important step for our analysis process. So once we do that, we have the data frame, right? And now, as you can see, it's all English language. Now we'll come to the fun part, the analysis. And you'll see this is where it becomes so much more interesting and so much easier. So now we import the plot from dataprep.eda module. Again, our DF has all these columns: index, created, text, truncated, language, right? So we want to analyze the text column because text column has all the tweets in them. So we run plot, then the DF data frame, and then the column name, so text. Once we run that, we'll have this distribution. So as you can see from the word cloud, COVID was the most common name, followed by cases, vaccine, HTTPS, covaxin, right? It also gives us a word frequency. COVID-19 has 415 counts. The next one is HTTPS, and then the cases and following, right? So do you see how easy it was to get all of this just using like one line of code, right? And this is to fetch both random and the COVID-19 one. Now we have another bonus example, right? So as we know, data connector has another connector called DBLP. So DBLP is basically to get information about a publication by a professor, by a research assistant, by research graduates, right? So as we know, Dr. Jianpei is known for data mining, right? So let's run this connector object and get 1,000 publications related to Dr. Jianpei. So let's do that. So now we have run that. And do you see how fast that is? Like it collected 1,000 ones, stored it in a data frame. So now this data frame has a publications table, and the columns in that table are author, title, venue, pages. So the one we are interested in is the title, right? Because title would have the name of the publication and the keywords. So let's plot that. So we have the DF, which is the query from the publication and the title. So let's run that. Let's go to word cloud. And as you can see, data mining was the most common, data mining and data were the most common words that were found in Dr. Jianpei's publication list, right? We also have a word frequency. So they both appeared 117 times, right? So as you can see, this is such an awesome library, like to visualize, to analyze, to do statistical analysis. In general, to make sense out of your data, this is an awesome library. And if you want to know more about the documentation, and if you want to contribute to the project, you can go onto this link. So here's our link, and you can read about the various methods and what you can do with this library. Also, if you find some bugs and want to contribute to an open source, you're more than welcome. This library has awesome documentation on how to contribute. So again, I hope you enjoyed the video, and thank you everybody and have a great day. Bye bye.